All right, welcome back, ladies and gentlemen. So now let's get into the notes for the sum and difference formulas. And basically what I wanted to do for this section is just give you a lot of different examples of how we can apply these sum and difference formulas or identities. And, based on everything we've learned, thus far. So let's kind of start with, again, one that we can verify. This is the cofunction identity. Hopefully you already recognize that the cosine of pi halves minus x, that's going to equal sine of x, right? So if these formulas are going to work, like that should give us sine of x. So here's our formula. So we have cosine of u plus v. All right. So basically when you have something like this, you can say this is cosine of u minus v, right? So we can say u is equal to pi halves and v is equal to x. Now don't make it a negative x, right? Because technically these are in parentheses, right? That's u minus v. So if you want to put them in parentheses, you can do that. So now basically all we're simply going to do is just apply them or plug them into our formula. So we can say the cosine of pi halves times the cosine of x. And then again, notice that this is minus. So therefore it's going to be plus inside the formula. So it's going to be plus a sine of u. So that's going to be pi halves times a sine of x. Okay, now if we think about on the unit circle, right, at pi halves, let's see here, that's right there. This coordinate point here is, let's just do a whole unit circle. That coordinate point is 0, 1. All right, so the cosine is going to be 0 times cosine of x plus the sine of pi halves, which is 1, times the sine of x. Well, again, what does this equal? This is just going to equal, guys, the sine of x, which we already knew was the answer. Now, we weren't like evaluating, like we just already knew that the answer was going to equal sine of x, right? So maybe I'll just kind of like put this over to the side. Like we already know the answer is sine of x, right? And you can see by plugging in the formula and by using the formula, we got sine of x, which, confirms that these formulas are going to work. And that's really helpful. That's really helpful because, like for instance, if I have tangent of 115 degrees plus tangent of 5 degrees, and it says to evaluate, how am I going to find the value of this? Because I have no idea what the value for tangent of 115 degrees is or the tangent of 5 degrees. Like no idea. I don't have those values for on the unit circle. However, if we recognize this to be the sum of two angles, right? If you look at this like tangent of u plus tangent of v, well, that means you're going to add the two angles. So that means this is equivalent to a tangent of 115 degrees plus 5 degrees. Oh, so that's equivalent to the tangent of 120 degrees. I can evaluate the tangent of 120 degrees, right? So if you see this expression, you can recognize this is just the sum of 115 degrees and 5 degrees, which is a tangent of 120. Let's go and think about 120 is going to be right there. So if we think about that coordinate point here, that's going to be a negative 1/2 comma square root of 3 over 2. So if you put the y coordinate over the x coordinate, that would give you a negative square root of 3. Okay? All right, let's just put it right there. So negative square root of 3. Not over 2, just negative square root of 3. And the same thing kind of works over here. Like sometimes students will go ahead and add these, or sometimes we'll be given our angles. Sometimes we'll given a function like this. The sine of, let's see, this would be 6 pi over 12. No, it's not 6 pi over 12. This would be 3 pi over 12 plus 2 pi over 12, which is also the same thing as the sine of 5 pi over 12. Okay, so sometimes students will see, or sometimes you might be given an answer that's written as like sine of 5 pi over 12. Well, we don't know 5 pi over 12 based on our knowledge up to this point of the unit circle, right? We don't know that angle. However, if you break that into 3 pi over 12 plus 2 pi over 12, and then you reduce that to pi over 4 plus pi over 6, you realize, oh, I can evaluate that though, right? Because again, using your formula, the sine of pi over 4 plus the pi over 6 is just going to be the sine of pi over 4 times the cosine of pi over 6 plus the sine of pi over 6 plus, not plus, times the cosine of pi over 4. And now for each one of those, I can definitely evaluate, right? So pi over 4, that's going to be square root of 2 over 2. Cosine of pi over 6, that's going to be a square root of 3 over 2. plus the sine of pi over 6, that is going to be a 1/2. And the cosine of pi over 4, that's going to be a square root of 2 over 2. Okay, so we're going to get a square root of 6 over 4 plus a square root of 2 over 4. Right? Now, there's a couple different ways we can definitely, 2 times 2 is 4. Yeah. So there's definitely a couple different ways that we can go ahead and simplify this. You could definitely just take out a 1/4, right? So you could rewrite this as a 1/4 times a square root of 6 plus a square root of 2. You could also factor out a square root of 2 as well. So you could take the square root of 2 over 4, and that would leave you with a square root of 3 plus 1. That is another simplified version, right? Or you could also combine them, right? You could just say this is a square root of 6 plus the square root of 2 over 4. So a couple different ways that we like to go ahead and that we can like to write these out. But those are all different variations that you will see, okay? Typically, students have trouble with this last one just because you're factoring out a term. You're factoring out that square root of 2. Typically, students like to either divide out the 4 or combine them together. Now, hopefully for these 3 examples, these kind of make sense. So therefore, we can make some sense of like, well, let's just trust the process then with adding the 2 angles based on if we were given a trigonometric function. So if I gave you the sine of u equals 1/4, and the cosine of v is 2/3. Well, again, like we don't have those values on the unit circle, so what should we do? We should create a triangle, right? So let's create a triangle. That's u, and that'd be sine, so that's 1/4. And then we'll do another triangle, which is going to be v. Okay, and that would be a 2/3. Now, hopefully, you're following me with the unit circle here, so that'd be 16 minus 1, so that's going to be square root of 15. Oops. Okay, and this would be 9 minus 4, so that'd be square root of 5. Okay, so you can use the unit circle, the Pythagorean theorem if you need to, but those are going to be your values, and here would be the angles, okay? And this is just based off the 2 angles here. So now it's saying find the u plus v. Okay, so if I remember the formula is sine of u is 1/4 times the cosine of v, which is 2/3, right? And then that's going to be a plus. Was that a plus here? It was a plus. Plus a cosine of v, sine of v. So that's going to be square root of 5/3 times a cosine of u. So that'd be a square root of 15 times 4. Okay, so in this case, we get a 2/12 plus, let's see, that's going to be 60. So that'd be a square root of 75/12. Now, again, I could redo that. I could simplify the square root of 25 to 25 times 3, which would be, and then I could take the square root of 25, which would be 5. So I could rewrite this as a 2 plus 5 square root of 3 divided by 12. And we'll just leave it like that. I mean, you could factor the 12 out if you didn't want it as a fraction, but we'll just leave that as their answer there. Okay, we can also look into using an example for solving using our sum and difference of 2 angles. So again, if we want to solve, like same thing, apply the operation. So this is going to be the cosine. You're not going to use inverse operations here. You're going to want to solve like the cosine of, now again, actually to qualify, you could actually solve this. You could actually solve for this for when is cosine equal to 2 pi square root of 2/2, and then use these inverse operations afterwards. So the only problem with doing it that way is then you still have to apply these all solutions method. So that's why I like using the sum and difference formulas just from the beginning. So I think it makes it a little bit easier from there. But I will show you a second method to get to the same answer, just so you can kind of see how this works. All right, so if I was going to use the formula, though, it'd be the cosine of 3 pi over 2 times the cosine of theta plus, right, remember it's the opposite sign, sine of 3 pi over 2 times the sine of theta. Okay, so cosine of 3 pi over 2, again, using unit circle, that's going to be 0. And then sine of 3 pi over 2, that's going to be a negative. So this would be a negative sine of theta equals a square root of 2/2. So divide by -1, divide by -1. Oops, yeah. So when is the sine of theta equal to a negative square root of 2/2? And you think about that and you say, all right, well, on the unit circle, the sine of theta is going to be negative square root of 2 over 2. That's going to be 4 pi over 4, so that'd be 5 pi over 4 and 7 pi over 4. So I can say theta equals a 5 pi over 4. Now, again, there's going to be no relationship between them, so that's going to be 2 pi n. And then also, it's going to be a 7 pi over 4 plus 2 pi n. All right. Now, another way we could look at this, which is a little bit odder in here, but you could also say, well, let's just make this be alpha. So if I said cosine of alpha is equal to the square root of 2 over 2, and sine is negative, right? So you say, when is cosine of alpha equal to square root of 2 over 2? And you say, well, that's going to be, cosine of alpha is going to be square root of 2 over 2, so that's going to be at pi over 4 plus 2 pi n. And then also, it's going to be at, let's see, that'd be also at 5 pi over 4 plus 2 pi n, right? But again, remember, alpha, we're not solving for alpha, we're solving for 3 pi n minus theta. So if you did 3 pi divided by 2 minus theta equals pi over 4 plus 2 pi n, then you'd have to go ahead and solve for theta, okay? And same thing over here. So then you'd have 3 pi halves minus theta equals 5 pi over 4 plus 2 pi n. So hopefully you can kind of see that that creates, like, it's a little bit more work, but you could definitely go ahead and do it for you in that case and just kind of be curious. This would be negative, if I multiplied by, or I'd multiply this by 6, that'd be 6 pi over 4. Yeah, let's just keep things simple. I'm just going to keep this from on there because that's a little bit, just too much more work than I really want to do. But that is definitely a method for those of you that are watching the video. You could definitely go ahead and follow. For some problems, it won't be as bad, but I rather actually use this space to talk about the unit circle. It'll be a little bit easier and be more beneficial, I think, for students. So square root of 2 over 2, so that's going to be from there, oh, there, and yep, there. And then for here is when it's at negative. When sine of theta is going to be square root of 2 over 2. There you go. Oh, that was a 3 pi over 2. That's what I was looking into. There you go. There you go. All right, so that'd be 0, negative 1. Perfect. Okay. And the last example I want to cover is just a verifying example. So how can we use verifying? Well, same kind of idea. Here, if we have verify, so that's tangent of u minus v. So again, this is supposed to equal tangent of theta. And you're like, how is this going to work? How is tangent of pi minus theta equal to tangent of theta? Well, again, using your formula here, so I could say this is going to be tangent of pi minus the tangent of theta divided by 1 plus tangent of pi, tangent of theta, right? And again, that's assuming that I wrote down the formula correctly. It's supposed to be the same, opposite end. All right. So we think, all right, well, what's the tangent of pi? Right? So again, going back to our unit circle here. Tangent of pi is right here. That has a negative point, -1, 0. So if you took 0 over -1, that'd be 0. So it's 0 minus tangent of theta all over 1 plus tangent of theta, which is 0. That's supposed to be a negative tangent. Right? Because that's a tangent of theta, 0. And tangent of pi, that becomes 0 times a tangent of theta. So that equals a negative tangent of theta. And so I'm going to put a negative there because that was wrong. I forgot to add that in there. So therefore, you can see it's verified. All right, so there you go, ladies and gentlemen. Those are some examples of how we're going to use sum and difference formulas. Now what we'll go ahead and do is we will just practice more and more of these examples so you can really get them refined as far as you're feeling comfortable with being able to apply them for all of these different types of solutions. But I hope these examples helped you out for understanding your formulas. I'll see you in the next video. Cheers.